Hello and welcome to another section in further mathematics. In this section we'll be looking into the topic exponential and indicial equation, or you can call it the indicial and exponential equations. But before that, let us review our previous lesson. Okay, welcome back. When we talk about exponential equations, it's an equation that has a power. For example, if you write 4x equals 16, this is a sign of exponential equation because it has a power with an unknown. So when you write an equation like 14 plus 9x equals 23, why all these are exponential equation? Because the unknown are used as a power of the equation. So let's go into solving some exponential equation. And we really need the knowledge of indices, just like what we did in our last class, to enable us move properly in this. Now the first one is, let's call it example number 1. Now in our first example, let's solve for x. Let's solve for x 1 over 2 raised to power x being equal to 8. Now remember what we did when we were solving questions on indices, when I stated the law of indices, the law of negative index. I said when you have 2 raised to power minus 1, it's the same thing as 1 over 2. So since we are having 1 over 2, let's convert it to 2 raised to power minus 1. So now have 2 raised to power minus 1 or raised to power x, and it's equal to 8. We are trying to convert it to indices. 8 is 2 raised to power 3. Now we also did something in the product product power law of indices, where we stated clearly that if you have a raised to power m multiplied by c, is the same thing as a raised to power mc. So we are applying it here now. Minus 1 times x is minus x. So we now have it as 2 raised to power minus x to be equal to 2 raised to power 3. Now you're taking 2 away from 2. So with this, minus x is equal to 3. But we are not looking for minus x. What we are looking for at this point is x. So in order to remake this, we multiply both sides by minus. This times minus and this times minus. Minus times minus makes x plus, and this is minus 3. So our value for x now is equal to minus 3. This is a very wonderful way of solving an exponential equation. We can still attempt it again by solving example 2. Let's solve more examples on this. Now when you have an equation of the form 3 raised to power x being equal to 1 over 81. Now the same thing we did here by raising 1 over 2 as 3 raised to power minus 1. We have to apply it here too. But let's clear this bracket. Since we have 3, that's to say we are dealing with 3. Now let's go into proper expansion. 3 raised to power 2 is 9. 3 raised to power 3 is 27. Then 3 raised to power 4 is 81. So we now have it as 3 raised to power x will be equal to 1 over 3 raised to power 4. Now we are still applying the law of negative power index. So we now have 3 raised to power x to be equal to 3 raised to power minus 4. Just like what we had here, our negative power index. If you raise it up, this becomes 1 over 3 over 4 is the same thing as this. So when 3 leaves with 3, the value of our x is equal to minus 4. If you just follow the way I'm doing it, you see that it's really fun solving an exponential equation. I would like us to solve one more question before we move into doing something else. Okay, can we just solve for 4 over 2 raised to power x being equal to 64 raised to power x. Now this is equivalent to 4 2 raised to power minus x, this is the bracket, then equal to, now 2 raised to power 2 is 4, raised to power 3 is 8, raised to power 4 16, raised to power 5 is 32, raised to power 6 is 64. So you now have 2 raised to power 6 raised to power x. But we have 4 here. 4 is equivalent to 2 raised to power 2 in bracket 2 raised to power minus x and equal to 2 raised to power 6 all in bracket with your x value at this point. Now with what we have here, let's do multiplicative. Let's apply a multiplicative law. When you remember when we stated the multiplicative law that you have a raised to power m times a raised to power n, that is equal to a raised to power m plus n. So we are applying it here. So this becomes 2 raised to power 2, this is multiplied 2 minus x, because this is equivalent to 2 plus minus x, which is 2 minus x, is equal to, then we are applying at this point, we are also stating the third law of power product. So this becomes 2 raised to power 6x, and with this 2 goes with 2, we now have 2 minus x is equal to 6x. Now let this minus x come to this side, we now have 2 equal to 6x plus x, and our 2 becomes equal to 7x, while the value of our x is equal to 2 over 7. So I think with this you've actually grabbed more on exponential equation. But some questions usually appear in the quadratic form. What if you now see a question of this nature, 2 raised to power 2x, we call this our example, this example 3, 2 raised to power 2x minus 6 in bracket 2 raised to power x plus 8 equals 0. Now if you see a question like this, remember this is 2, this is minus, this is plus. It's not the usual multiplication and division that we usually have. So one thing we need to do is, let's convert this into this form. You know this is equivalent to 2 raised to power x all square, because 2 times x will give you this, minus 6 raised to power 2x plus 8 equals 0. Now the essence of doing this is because I want to have this same value here at this point. So when you do it like this, you get the value. We can now say let 2 raised to power x be equal to, let's use the word a, capital A. So this thing, because anywhere you see 2 raised to power x, you put a. This becomes a square minus 6a plus 8 equals 0. We've gotten a quadratic equation. Now this is a quadratic equation. Now let's go into solving the quadratic equation. Now in solving this quadratic equation, what are the factors that can go into 6 and minus 8? I think it's minus 4 and minus 2. Minus 4 and minus 2. We are factorizing. So we factorize minus 4 minus 2 is minus 6. Then minus 4 times minus 2 is plus 8. Okay, so minus 4 minus 2. So we now have a square minus 2a minus 4a plus 8 equals 0. We are factorizing now. So what is common between these two is a, in bracket we have a minus 2, and at this point we have minus 4 is common. We now still have our a minus 2. We're just performing direct factorization. So this is a minus 2 and a minus 4 equals 0. So our a is equal to 2 or 4. Now these are the two values of a. But remember, what we are looking for is x and not a. So the values of our x, now remember the relationship between a and x, this. So with this, the value of our x, remember our 2 raised to power x is equal to a. Now you look for the value of x when a is equal to 2, because we have 2 here. So when a was 2, our x is 2 raised to power x is equal to 2 raised to power 1. 2 goes with 2, so x will be equal to 1. That's the value of our x. Now when a is 4, when a is equal to 4, what will now happen is that the relationship again, 2 raised to power x is equal to 4. So 2 raised to power x is equal to 2 raised to power 2. So 2 goes with 2. Our x is equal to 2. So the values of our x is equal to 1 or 2. Now with this, I think you will bear with me that solving exponential indices is usually very easy. That's just if you can apply the rules that governs indices, you will see yourself on a wonderful and outstanding nature when it comes to indices and its calculation. But thank you for joining us in this lesson. And to refresh your memory on what we just discussed, a question will be popping up very soon. Do yourself good by attempting the question, and also do well to always use the lesson notes on this platform for a better information on the topic we've just discussed.